One and all respected sir, ma'am. My name is K. Rishika Reddy. I am from EC department. My subject is machine learning, and my AAT topic is about pan-European high resolution downscaling using deep learning. Let's begin into the tech talk. Here is an introduction to high resolution downscaling. High resolution downscaling aims to generate finer spatial data from Oscar climatic or environmental datasets. It is essential for detailing regular analysis and decision making in areas like agriculture, urban planning, and climate adaptation. Deep learning techniques have recently gained properly propagation due to their ability to model complex spatial patterns efficiently. Efficiently is nothing but the parallel downscaling of data in agriculture. In agriculture or planning the climate adaptation, deep learning techniques have been recently gained promotional due to their adaptivity to model complex spatial patterns effectively. Coming to next slide. Importance of pan-European downscaling. Pan-European downscaling provides consistently high resolution data across diverse countries and ecosystem. It supports cross-border environmental management and policy formulation. Accurate downscaling enhances climate impact assessments and resource management at continental scales. Coming to the next slide. Here is the challenges in traditional downscaling methods. Traditional statical and dynamical downscaling methods often requires extensively computational resolve. They may struggle to capture complex local features and nonlinear relationships in spatial data. These limitations motivate the exploration of machine learning and deep learning approaches for better accuracy and efficiency. Coming to the next slide. Deep learning for spiritual downscaling. Deep learning models such as convolution and neural networks are also known as for CNNs can learn future from large data sets. They excel at non-linearing and linearing methods, which are also known as a particular area of the demanding models requires training data but offers improved performance. Overall traditional methods are also known as for deep method learning analysis. Deep method learning analysis is also known as deep data structures. Deep data structure is divided into subparts. Coming to the next slide. Methodology for pan-European downscale. Methodology is nothing but the RI and SI units of data which is compared by pan-European downscaling. Pan-European downscaling is also known as pan-European data of demanding structures. Pan-European data structures are also known as down-European structures. Pan-European structures are also called as involving all most nationals across the European continent aiming for political economy or crucial units. Crucial units are also known as pan pan world of demanding data. Pan world of demanding data is also called as downscaling of structure. Here is a graph given in the picture which the graph states about demanding the basic ground down state etc. Trained models are adopted, then the applied to downscale across data sets across the entire European domain. The process involves training deep learning models on paid data sets of across the high resolutions observations data. Solutions includes imaginary climate models and ground-based measurements. Down-graded measurements is also known as learning models of paid datasets. Paid datasets is also known as high observations. Coming to the next slide, case study and applications. Case study and applications are also known as Case study and also applications are also known as recent studies have been successfully downscaled temperature prescription and based upon land cover data across European using deep learning. Applications includes improved climate assignments and enhanced environmental monitoring. These case studies demonstrate the potential for operational use in policy and planning context. Model chains are also known as downscaling. Downscaling is nothing but model chains. GCM is also known as for static downscaling. Static downscaling is also known as representation of alpha region. Coming to the next slide, advantages and limitations. Here is a advantages. Deep learning based downscaling offers higher spiritual details, accuracy and adaptivity to deliver data solutions. However, they require large amount of high quality training data, significant competition resolutions. Model interpretation remains a challenge, promoting ongoing research into explainable AI methods. AI methods is also known as advantages and limitations. Deep learning based on downscaling, higher spiritual design data, accuracy and adaptivity. Coming to the next slide, future directions and opportunities. Future direction and opportunities are multi-source data including remote sensing and social economic data sets can improve model robustic transfer learning demanding adaptivity techniques can enhance model transferability across religion. Developing user-friendly tools and open data sets will facilitate broader adaptation of deep learning downscaling. Here is a reference of included relevant academic papers. I would like to conclude that I have learned many things by this tech talk. I would like to thank respected sir ma'am for giving me this tech talk topic. Thank you so much.